we used to say this, what's not there, like the technology that is not there, the electronics that is not there to break. So we are saying as simple as possible technology. Passive technology means you don't need to have any motor, any regulator, any servo motor, any energy to be spent to regulate. And this is the particular niche where we don't see other competitors, and that's more or less how the market is.
Today I brought on Tommaso Morbiato, co-founder, CEO, and the head of research and development at Windcity. Windcity is a company that has passive variable geometry wind turbine technology that allows for low-altitude wind energy harvesting with a 25-year lifespan and with rooftop-ready modules. We talk about how Windcity is solving inefficiencies in the wind energy capture at low altitudes, as well as overall wind turbine innovation and his company's pilot partnerships. This is Earth ABC featuring Tommaso Morbiato. So, Tommaso, not only are you a founder and CEO with tons of experience in structural engineering and wind energy, but I was also pleasantly surprised to learn that you're also a professor. So I'm very excited to learn more about wind technology from someone who knows it the best. So welcome.
Thank you very much, Sian. It's a pleasure for me to be hosted by this fantastic operation and initiative.
Yeah, I guess to kick things off, solar and wind energy are like closely related. But to what extent can we say that solar and wind energy technologies are similar?
Well, yes, in many ways they are. Actually, it's randomly governed renewables from nature, but in one crucial way they aren't, because sun varies just with geographical coordinates. So you put north and east, and you may find just different solar irradiation in surface. But wind changes also in height and completely, because it is regular at high altitudes, let's say from 50 or 80 meters from the ground on, but it comes completely turbulent in low altitudes. And turbulence means gusts, and gusts only have a duration of 2 minutes, and it's like 2 minutes trains of wind that can change direction, can change intensity. So it's really complex natural source in low altitudes.
I imagine that there is some type of like market problem where at these low altitudes, there hasn't been something that is able to capture the gusts of wind from different directions.
Actually, this is an excellent question. And if we go back with the patent history in wind technology, we go back in 1931. Is a US patent from Darrier. And after it's done with the patent, he's putting a figure which is illustrating the fact that, oh, my turbine will not work in gusts. And from that moment on, everyone has been searching to solve this problem. But still, there are some that are trying to go to the market, some that already arrived, and we are one of those that succeeded in having a technology that it does go well with the gusts, and it does perform well with the gusts.
Nice. So it took 90 years for you guys to come along. How exactly do you go about harvesting this wind energy at the low altitudes?
We can say there is pretty much we can say an Australian school coming back from the 90s, where basically the idea is you need the turbine to understand, like to learn how to sail, and also how to go to be like an airplane, sails and planes, air wings, they're not fixed. They change the pitch, and instead, if you look at wind turbine, that was a technology that for so long it goes with fixed blades, and this is good for high altitude where the wind is regular. But if you go with turbulence, basically what we do is we let the turbine adjust the blade angles and the radius as if it was in a sailboat. And what we do differently from anybody else is that we do this, we can say, with this name that we gave to our technology, is a passive variable geometry. It means it naturally dialogues with the wind, and it changes the angle based just in centrifugal force, aerodynamic forces, and you do not need to spend energy to regulate the blades. And this is very important because if we're talking turbulence, we're talking low altitudes, we're talking small wind turbines. So if you start spending energy to have motors to regulate the blades, you're not getting energy balance, you know.
Got you. And then because these gusts are in 2 minute like spurts, they could come from one direction, and then after like some amount of time, there's another 2 minutes of another direction of the gust. So if it was like an active system, you need to have someone who manually changes the configuration of this wind turbine. And what you're saying is you built a technology that is able to self-adjust according to the winds and capture that energy. Is that correct?
This is it. Yes, this is it. You
This
can
is
find.
awesome.
Yes, we like this technology. We're a bunch of technicians that also enjoy going sailing, and we can say that it's pretty much contamination of the two worlds, the world of sailing and the world of wind energy. Yeah.
That's cool. And in terms of this like passive wind turbine, how come it wasn't possible before?
Well, this is where comes also my partnership with my partners, because if you go and look at all the PhD thesis and all the research done in this field, there are some ideas, but then you know, when you have these parts moving, you get bumps, you get impulse behavior, you get durability issues, and cinematics. So motion is not as easy to regulate and to have it with durability and performance. And my partners, basically, they are industrial automation company from 2 generations, and so any idea you know that one engineer can have was validated by their knowledge of the market, of the parts that need to move, like in industrial automation. So we can say our technology is really a contamination between sailing, wind energy, and industrial automation.
Makes a lot of sense. So when you have this technology installed, like what do the benefits look like? Like who are the customers, and when they do capture this energy from these like low altitude like gusts, like what type of energy production do they see and what is it used for?
Sure. As a validation of the technology, we had the chance to be involved in a Horizon Research Innovation Action, where we actually built our wind tunnel testing facilities. And first thing, we blocked all our features and we measured the performance with gas. So we measured the performance in gas of a fixed blade turbine. Then we released all our features and we measured again. And as you can also find from our website, we measured plus 65% of energy. And actually, after this, there is also a super nice article from Nature Communications, and where the last year, 2024, they acknowledged that this type of regulation in small wind turbines is the optimal control you can have to have the best performance. Our customers, we found this close match with this fantastic early adopting customer for us, which is airports. Because airports, if you think about it, they are naturally built in windy locations because headwinds actually
Right.
it does optimize and put safety in takeoff and landing. The more headwind you have, the more stable is the plane when it goes takeoff and landing. And on a secondary, but not so second part, let's say on completely the same level, uh, airports are also business that they have a huge need for cleaning the technology that they use. So for cleaning their carbon platform of the carbon footprint, let's say, of the airports. And this is a win-win situation for us, and because we can go install it in rooftops, and actually they have a lot of flat rooftops, and we are having good experiences so far, close to the airport of Thessaloniki in Greece, the airport of Madeira Island in Portugal, and now close to the airport of Pantelleria Island in South Italy. So uh, actually, this is our first customer segment, and but also we are in close connection with pilot customers from telco towers, where we can decarbonize the telecommunication industry, and also with water tanks. You know, water tanks, there are towers at a high
Yeah.
altitude, where on top of that we can put our small modules for having what we can say naturally built towers. This is also a good part of the story, because in wind energy, 30 or 40% of the cost is the cost of the tower. So if you find telco towers and water tank towers that they are already high, basically
Right.
you can save all the cost of the tower.
Hmm. And because you could install them like on the tops of like airports on like these like water tanks, I imagine like they're nowhere near the size of a huge wind turbine that you would have at these like high altitudes. So in terms of like the main product that you're talking about, what does it kind of look like, and what do people expect when they do purchase it?
Yes, we can say that one model of ours, basically we can go for two type of modules. We have a 2 kilowatt module and a 600 watt module, and but you can assemble that in many ways, and in order that each of our modules is worth like 20 square meter of photovoltaics. And you have also ways which were studies actually in the US, in Colorado uh, flow laboratory, to put turbines very close to each other, contra-rotating, so that they can be placed close to each other and have increased power. So
Mm.
this is really a way to optimize the surface, and you can expect to have about 3 to 5 megawatt hour per year per each module. And this is a way to have a return on investment in about 3-4 years. Of course, you need to find good windy locations, and but this is nowadays very easy, because you get um, databases as the Global Wind Atlas, or data that comes from satellites, and it's
Right.
very easy to have wind data at low level of the ground, like 10 meters, 40 meters, whatever.
And when you say 3 to 4 years to see ROI, are you referring to when they break even or when they see like some X amount of profit?
Yes, basically the way we calculate this is you get the kilowatt hours per year, uh, you get the price of 1 kilowatt, and you multiply this, so you have like price discount per year of use. So when you arrive to the price that you paid, you have return on investment, and from that moment on, which we have uh, designed our module to be a 25-year lifespan module. So you still have like 20 years of um, extra energy that you can have.
Got you. And 25 years of a lifetime is actually pretty long. I imagine that there's like some wear and tear that does happen just through nature. So to what extent does performance degrade over time in that 25-year frame?
Actually, you need to be careful about two main topics. One is content of salt in the air, and by like if you are installing near the sea or near the ocean
Uh,
in an island, and in that case, we have uh, um, yeah, we have optional components that goes stainless steel, and by that way, we're going like to transform our wind turbine like if it was a sailboat. Actually, sailboats have the way of resisting in salt, so it's just a matter of a small extra price, and you have all the components that are uh, water salinity proof. And the other part is about rotating parts. So rotating parts are like ball bearings and this type of machinery. And actually, the maintenance period that you can expect is about 20,000 hour. And 20,000 hour, if you think of the fact that in 1 year, one turbine, it has a capacity factor of 1/3. So let's say 3,000 per year, 3,000 hour per year, then you can see that you don't need to worry about maintenance in terms of lubrication of the bearing of the parts, not before 5, 6 years or 7 years. So this is basically what we also are seeing from our first pilot installations in 2019, that we are about now to do the first, let's say, inspections that go with some maintenance effect after the inspection.
Gotcha. Wow. Okay. So you guys can pretty much handle wherever your potential client is located. So you've accounted for not only like the altitude, but also like the proximity to sea. So how much salt is in the air, um, and a bunch of other variables too. So very, very cool that everything is accounted for. You mentioned, I think a couple of times how you had like two modules. So I imagine that there's like a family of solutions involved with Windcity.
Great.
Um, so could you share more about like what the suite of solutions looks like and how compatible like your products are to other, um, I guess, ecosystems or infrastructure?
Yes. Um, Basically, the 2 kilowatt module, which is the one that is very much covered in our website, is we took the best performing vertical axis wind turbine if it was an ideal regular wind, and we like transformed this in a, gusty proof Darrier wind turbine. And so this is, let's say, our let's say Ferrari module. And then we have another product which we love to say that is a concept of West idea of technology meeting East idea of technology, and this is a hybrid turbine that is an ancient patent of Taiwan, which is now free of use, and you can see a lot of these mini wind turbines installed in Taiwan, where the hybrid idea of having an inner rotor and an outer rotor collaborating together, where the inner rotor is making the acceleration part, is a very good idea. And we sort of increased the performance because we applied some contamination of technology from the cycling tech, and we allowed the 2 turbines also to be disconnected as if it was the wheel of a bicycle, and this allows really the 2 turbines to work separately. And we measured that we can achieve up to 60%, 65% more energy. And then we have another part of our patents, which is dedicated to safety, because in wind turbine is very important to know also how to brake, because sometimes the wind can be very extreme, and you have a hard time braking. Actually, standard wind turbines have problems either when the brake does not work because they go over speeding. But
Oh,
even,
right. I've seen videos of that happening. Very
yeah,
scary. Yeah.
yeah, very scary. But actually, you can also have problems when the brake does function, because in some case, when the wind is too much, braking technology transfers, braking couple by friction, and friction becomes heat, and then heat becomes fire. So what we developed is basically an aerodynamic brake, and we have the first in the world installed in Madeira Island. And we love to say that this is basically a technology where the more the danger comes and the more the safety comes, because it is basically a technology that when the wind is increasing, just by centrifugal force, the blades go like out of their optimal angle, and they break by themselves. So the more wind comes, the more braking effect you have, and there is no friction, no heat, no nothing. And this is very good because we started selling also this technology to higher rating turbines, also for third-party turbines. And we are very proud of this because we can really help in the safety of the technology, so gaining reliability worldwide in the wind energy technology.
Yeah. I think safety is often like overlooked sometimes, especially with like hardware. So love that you guys not only consider that, but have like that patent. Like I believe you said it was pending, right?
Yes, this is patent pending. Yeah,
Pending. Okay.
basically part of it is already covered by one of our patents, but we had confirmation that we can go for a additional patent now that we have this realization.
Got it. And I know that for your earliest of customers, like their airports, or a lot of them are airports, and they have like solar stuff installed on their rooftops. So how compatible is Windcity with like these assets already installed on these rooftops?
Yes. Well, in terms of comparison, I was telling you is like one turbine of one of our 2 kilowatt modules is worth 20 to 25 square meter of photovoltaics. In terms of synergy, we absolutely love synergy with photovoltaics. So we don't mean to be like an alternative, and that's why we developed in our family of products power board that allows the wind energy to be delivered to any standard photovoltaic inverter. So basically, we can be compared as a string of a photovoltaic. So whenever the customer already have an inverter that has a string uh, input module free, we can plug in and go together with the photovoltaics. So yeah, this really was the idea to be in synergy with other renewables, not to be alternative, you know?
Most definitely. This is really exciting technology. Something that was never on my radar. So I'm also learning a lot in the way that you're explaining things. Very much could sense like you are a professor, you know what you're talking about. So very easily understood. And I imagine though, because of the opportunity here, there's other competitive players in the market. If there isn't, I'd love to hear like why that's the case. And if there are competitors, what is Windcity's value proposition? And maybe like you guys have any particular recognitions, would love to hear that as well.
Yes, thank you. Of course, I told you before, Sian, the I mean the technicians and the engineers, the experts in this field, they are trying to solve this wind turbine in the gas problem since 1931. So, of course, there are competitors, and basically, you know, we can go in two families: horizontal axis wind turbines and vertical axis wind turbines. So we're not horizontal, we're vertical. In horizontal axis, there is a very good competitor, which is a Japanese company. Air Dolphin is the name of the turbine, and they have this intelligence. So they have like an algorithm that understands where the wind comes from the tail. So this is how they try to behave in good manner with the gust. So the turbine will not just move as a flag, you know, but they will, after 1, 2, 3 months, it will know, okay, I'm staying here because I know the gust will come here again. And by that way, they say they solve the problem of about 30% more energy compared to fixed uh, technologies. And in terms of vertical axis wind turbine, I can tell you that other technologies are there that do have variable geometry, but as I was telling you before, they do active variable geometry. This means you need to have plugged in power to regulate the blade, to regulate the pitch, and spend energy to have these regulations. And as a matter of fact, we are not seeing these technologies worldwide or even in a niche market applied, because you have also reliability problems. We used to say this, you know, what's not there, like the technology that is not there, the electronics that is not there to break. So we are saying as simple as possible technology. Passive technology means you don't need to have any motor, any regulator, any servo motor, any energy to be spent to regulate. And this is the the particular niche where we don't see other competitors, and that's more or less how the market is configured. Um, so what we can say is that the other uh, part of competition is, as I was telling you, the hybrid turbines that you find from the East market. And in that case, also, we have this technology that can arrive to harvest almost 60% more from the gusts, because we have this second family of patent that arrives to unlock the two axes as it is for the wheel of a bike. And by keeping on adjusting, our technology to the way the wind is really made by nature, that is variable, we are trying to stay on top of the competition. Actually, our payoff is energies from a variable nature, and we are used to, hear the frequency, hear the soul of the wind, and adapt to how the wind is made with our technology. Not to pretend that the wind is regular and that you just go with a fixed with turbine, and because, as you said before, since 90 years, it didn't work. So
Yeah. I think, like you mentioned before, there's a lot of different approaches with the technology, whether it's like horizontally aligned or vertically aligned. And to your point for your technology, one of the unique parts is that a passive nature for these wind turbines. And I think that I also do see the uniqueness now and the power that it gives to the people who are looking for more energy efficiency, and that the passive aspect definitely unlocks it. And while we're on the topic of like years spent on this technology, Windcity, you guys have been operating for almost a decade. So before we close out, I'd love to hear what the next 10 years has in store for you guys.
next 10 years, we need to install a lot of these modules. We are we want to answer to the question that our customers looking for big business case and large scale deployment go ask, like, how many of your modules can stay in our 5,000 square meters? And we want to be able to say, okay, yeah, 5,000 square meter, it's 800 of our modules. We can deliver this to you in 3 months. This is where we want to arrive, because another picture from the east, if you go in Taiwan, you can see that you have these wind farms of large scale wind turbines, and then on the lower level you have like a carpet of all these small wind turbine modules. And this is very intelligent to do, and we want to also contribute to do this, because what's the point of not harvesting the wind that is blowing below the last part of the wind blade? You can harvest all the wind that is below that, but you just need the correct technology, and we can contribute to this. And so in our next 10 years, we can arrive to deliver 2,000 of modules per year, and this is really where we want to arrive. Also, with our safety technology, we can help higher rating companies to achieve safety, passive safety in their applications, because we can go licensing with that.
Right. It's also going to be another revenue stream.
Yeah. I forgot to mention, maybe it was one of your questions about certifications that we have. We have certification from the Solar Impulse Foundation in Switzerland. We got the Efficient Solution label from LCA and from the Passive Variable Geometry. And then we are designing and producing according to CE mark for machinery, and is also already accomplishing the ISO EEC 61400 Part 2, which is the standard worldwide recognized code, technical code for small wind turbines. So we try to do that, to be already accomplishing the need for regulation.
For sure. Seems like you guys are very thorough technology and thorough company in your technology.
Well, it is not like a solar panel. A solar panel is a static panel that you put on top of your rooftop. This is an object that speeds like 200 RPM on the rooftop. So it needs to be something really safe, something really thorough, as you said.
Yeah. Well, thank you so much for taking the time to chat with me. Again, like very much like the professor side of you shown through. I learned a ton. So thank you, thank you, thank you. And
Thank you
very
too.
much rooting for Windcity success as well as yours.
Thanks, Xian, and good wind to you and to everybody of your audience.
Thanks for tuning in. If you enjoyed this interview, follow along on EarthEBC's LinkedIn to stay connected and never miss what's going on in climate tech. If you'd like to reach out or you're interested in coming on as a guest, feel free to connect with me, Sean Pack, on LinkedIn. We're always looking for inspiring ventures and founders in the climate space to feature on the show. Hope you enjoyed. Until next time.